Now let's look at string comparisons. Like floating point numbers, when we're comparing strings like in an if statement, we run into some issues in that we can't compare them equal. So let's just talk, what does it mean for two strings to be equal? The computer will compare each letter, letter by letter, and is very, case sensitive, that sort of stuff. So go through these and look and see what they are equal. So again, it's comparing letter by letter to make sure these are equal, make sure they're exactly the same upper and lower case spelling, or words. So they're only equal if every letter is exactly equal to the other ones. Now, our problem comes in is when we want to use the equal equals to check if two strings are equal. And this isn't going to work. Strings are stored as objects in Java, and with objects, Java actually stores the address of a string when we look at things like this equal equals comparison is equal to. So if we want to say if string 1 is equal to string 2, we have to use a different format for it, because really what it's looking at is if string 1 is stored in the same memory location as string 2 is, and that's not what we want. With small programs that actually does work about half the time, but it won't work the other half of the time, and in larger programs it rarely works. So we have to use this string 1 dot equals and then string 2. Write that out. So like if we want to see if string 1 is equal to apples, we would write is string 1 dot equals, and then here's the second string, and since it's a constant, we put in quotes apples. So that's what we're storing here, or checking out here. So go through these exercises and see how this is working. There's a nice Harry Potter themed question here that you can do, read through. I want to show you an application of this before we get to compare to. So last unit we looked at blackjack and a card class, and inside the blackjack class we asked the user if they wanted to have another card, and I said at that time, we can't use strings, so we said, do you want another card? 1 for yes, 2 for no, and we read that into an integer. So let's change this so that we actually ask for a string, because now we could compare strings. So I'm going to just say, do you want another card? Yes or no. And then we have some variable here to get the response. Sometimes we call this student or user hit or user answer. I just called mine response, but it was an integer. I'm going to change it to a string. And I'm just going to go scanner, and rather than reading the next integer, I'm just going to say next, which will get the next word. So I'm going to say, do you want another card? Yes, no. And I'm going to declare a variable called response as a string. Okay, so now we have our response here, and we're going to check if the response is equal. Now we were checking if response is equal to 1. We're going to check if response is equal to, now we're going to try this, and this isn't going to work. Because this is what you'd first want to do. If response equals yes, then we deal out a third card here. So when I run this, it shows me my cards and says, do you want a third card? If I say no, that does work. But let's try this again and say yes, and that's not going to work. Again, notice there were no compile errors. This compiled without any problems. That was one of the problems with this, is that it compiles fine. Now, let's say I say yes here. It's still not going to give me another card. It just goes right on and does the dealer's cards. So it ignored this yes. This was not true, because again, this response is stored at a different location as this constant, and so it's just comparing memory locations, and that doesn't work. So we need to change this. We need to say response dot equals, and then put the yes in parentheses here. Make sure I have the right number of parentheses here. I'm starting 1. Yep. So response is the name of my string variable, and I call a method dot equals, and then put the other string in here, and this is just a constant, so I can put it in quotes here. So now I can compile that and run that. If I say yes, Okay, where I said yes here, it says you're dealt a third card and gives me my 10 of hearts and stuff. So it does work now. And now it works as long as I type in yes exactly the way it is. So let's say I run this again and I were to say yes in all lowercase, that's not going to work. I don't get a third card. Or if I were to say, get really mad at it and say yes in all uppercase to see if that works. That also doesn't work. I don't get a third card. Because again, it checks exactly uppercase Y, lowercase e, lowercase s. If my word matches that exactly, then it will do this. And we'll handle that in just a sec. Let's jump back to Zybooks. Okay. Now, sometimes you want to not just check if one string's equal to another, but figure out if one's less than or greater than the other. Now, how do you know if one is less than or equal to another? So let's say we're comparing two strings, two words, apple and pear. What are we comparing? If we want to know if is apple greater than pear or apple less than pear, or they're not equal. I know that much. So are we figuring out what is the average weight of an apple, an average weight of a pear, number of calories in an apple, number of calories in a pear? What are we checking? And all we're checking is that how are they alphabetically, lexicographical comparison. So A comes before P in the alphabet. So it's like in the same way as 1 comes before 17 in the alphabet, numbers. So apple is less than pear because A is earlier in the alphabet than P. Similarly, if this was another word, so if this was another word, we check the first letters, and if they're the same, we move on to the second letters, and if they're the same, we move on to the third letters. So now P, it comes after A in the alphabet. So now this apple is greater than apartment, because again, simple alphabetical or lexicographical comparisons, this alphabetically comes before that, so this is less than that. So that's this compared to. So you can say string 1 dot compare to string 2, like here, string 1 dot compare to string 2. Now, if the two strings are equal, that'll be 0. And generally, we're not worried about that because we have the dot equals to check if they're equals. But if string 1 dot compared to string 2 is less than 0, then that means that string 1 is less than string 2. If string 1 is, if this ends up to be a positive number greater than 0, that means string 1 is greater than string 2. Now, we won't be using this much in this class. It's good to be aware of it. But later on, when we start alphabetizing sets of words or names and things like that, then we'll use this compare to more often. But there's some quick questions on how to set this up and use this. And again, go through these participation activities. Now finally, they just mentioned this real quickly here. There's an equals ignore case and a compare to ignore case. And these are used more than I thought they should. There's just kind of mentioned almost in a footnote here, but we will actually be using equals ignore case quite a bit. For example, in this exercise over here, where you're comparing if their response is yes, you really don't care if it's how they capitalize it. So we'll say equals ignore case here. And so ask yourself, anytime you're using dot equals to compare two strings, should you be using dot equals ignore case? In a lot of cases, you might want to do that. So here we're doing equals ignore case. And again, I can run this. Let's see, do I want another card? And I can say it in all lowercase and all uppercase or whatever, and it'll ignore the case and display that card for me. Okay, so back here, a couple challenge activities. Again, these are optional for this. Again, if the user enters quit, you just want to check for this user string. If the user string is equal to quit, you want to print out goodbye. Otherwise, you want to print out hello. So you just want to print out one or the other of those. And this is a comparison operator that you can work with. And here you're assuming the strings are lowercase, and you're just comparing the two strings. So that wraps up string variables. So just be aware when you get to a point and you're writing something and you are comparing if one string is equal to the other and it's not working, that you can't use equals equals. It'll compile fine and run fine, but it just won't produce the result you want until you switch to a dot equals.